Most of the time, the borrow checker is just enough, but sometimes you need a little more. Well, RC lets many parts of your program own the same value at once. And RefCell lets you change a value through a shared reference, which is checked at runtime. Each one trades a compile time check for a capability that we might need in our program. Box is the simplest smart pointer. Box new takes a value and moves it into the heap. The box owns that value. When the box goes away, the cat is freed and there's no garbage collector. And you use it like the value itself. Cat.name reaches right through the box. This is where box becomes necessary. A cat's ancestry. Each parent has a parent, and on and on. Without box, the compiler can't size it. A parent holds a parent. A parent holds a parent holds a parent. It's like forever. So the box fixes it. A box is a pointer of known size, so the whole type gets a fixed size. The star operator follows a pointer to the value behind it. The star box gives you the cat. Deref coercion is the quiet magic. If you pass a reference to a box where a reference to a cat is wanted, and Rust actually just converts it. That is why methods and reference just works through the box, RC, and every smart pointer. RC wraps a value and starts a reference count. Right now, one owner holds this ancestor. RC clone does not copy the cat. It hands out another owner and bumps the count to 2 and then 3. When the last owner goes away and the count hits 0, the cat is freed, shared, and there's no copies. RefCell lets you change a value through a shared reference, something the compiler normally don't let you. So borrow mut hands you a mutable reference, but the borrow rules are still enforced, just at runtime now. Ask for 2 mutable borrow at once and it panics. Instead of refusing to compile, still saves just the latter. If you stack them up and you get a famous combo. So RC on the outside gives you many owners of 1 rosters, and RefCell on the inside lets every one of those owners change it through a shared reference. So one cat pushes a name and the others see it, shared and mutable and single threaded, and the graphs actually lives there. The drop trait lets a type say what should happen when it is cleaned up. You never call drop yourself. Rust runs it for you the moment the value leaves the scope. So the carrier releases its cat automatically. No try finality or no defer. The cleanup is in the type. It's like it's within the type. Here's the whole chapter in one part. So match the need to the pointer. Well, a value on the heap or a recursive type reach for box. Many parts need to own the same value, then of course reach for RC. you need to mutate through a shared reference, then reach for RefCell. And when you need both at once, combine them. This is the toolkit. Well, that's mostly it.